Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. So before the beginning, let me check the audio and video. Yes, so I'm live and sound. Yeah, sound is perfect. So here is my profile. I am Jeetendra Dixit. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. So today we'll continue sequence and series and we'll do part Sigma. We'll understand Sigma today. But before the beginning, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform. And once you get the subscription for IIT-JEE plus subscription, then what are the things you can access? Let me explain those things. So you get access to daily live classes of all the JEE educators who are teaching for physics, chemistry, and maths. And you can watch their live sessions as well as recorded sessions. So you can download the recorded sessions and watch them offline. Even if you don't have the plus subscription, then you can always access unlimited special classes. So every day, many of the educators are taking special classes on the platform, so you can watch unlimited special classes. These are completely free. All right. So there's a lot of stuff which you get free, like these YouTube videos, YouTube live sessions. These are also free on the platform. But if you're getting the plus subscription, then you can access all the courses taken by the educators systematically. All these courses are well structured, so you can see the planning. I mean, all the schedule of educators, all the upcoming lectures in well advance. Live test and quizzes. Quiz feature is also there, like special classes, which is free, so uh, you can attend unlimited live quizzes. But the test series and quizzes which are on plus platform, those you can avail when you get the plus subscription. All right. These are the charges for plus subscription. You'll have to pay 38,500 for 12 months, and this will be after 10% discount is 34,650. Similarly, 24 months it is 56,000. All right, and after 10% discount, you'll have to pay 50,400. All right. There's one new feature added to the platform, which is iconic subscription. So let me tell you about this. So when you get the iconic subscription, you get all the benefits of the plus, which I've just told you, plus all the benefits of plus. Apart from that, you get a personal coach. All right, personal coach which will guide you. I mean, an expert which will guide you for all the exams. All the exams means all the engineering exams, top exams like advanced and main and bids and all. All right. So you can the expert will guide you throughout your preparation. It will align all the strategies and everything. Test analysis will also be there. So test analysis will be personal in a personalized way, and study planner will also be provided to you in a personal manner, customized to you. All right. So all these personal, I mean, things will be added in plus subscription if you get this iconic subscription. All right. And these are the charges of iconic subscription. You'll have to pay 56,000 for 1 year, and if you use my code JEET1, you'll get 10% discount. It's 50,400, and this is 2-year subscription. 86,000. You'll have to pay 77,400 after 10% discount. All right. You can download this Unacademy's learning app from Play Store, and after that you can take the subscription, either plus or iconic. So as per your requirement, you can go for iconic or plus subscription. So let's start today's session, which is Sigma. So first, this is the Sigma notation. All right, this is called Sigma notation. And what does this represent? This represents the summation. So whenever you have series like this, T1 plus T2 plus T3 and up to, this is the Rth term. All right, you can take Pth term, Rth term, any general term, and Tn. So how can you write this series in terms of sigma? You can write the general term of this series, that is rth term or pth term or mth term, nth term, you can choose any variable. So rth term, tr, inside this sigma, and put the limits. So if you're putting the limits, tr from 1, so that means this series will start from, if you put r is equal to 1 in this, that will give you the first term, and the last term will be n. So in sigma, this r is r can start from 0 also. If you have t0, then you can start r from 0. All right. So what is this written? Sigma tr means summation of all the terms in which r is varying from 1 to n. All right. This is sum of all the terms. So this summation can be written as this sigma form. There is a short form of writing this series. All right. Like for example, you have 1 square plus 2 square plus 3 square and so on up to 100 square. Okay. So despite writing this, you can write sigma of, write the general terms. You know it is 1 square plus 2 square plus 3 square. So rth term will be r square, right? And r will start from 1 to upper limit will be 100 because you are ending at 100. So these are the limits. If you put r is equal to 1, you'll get the first term. If you put r is equal to 2 in this, you'll get the second term, and keep adding these terms. All right. Put plus sign between any two consecutive terms. So this is sigma notation. So I hope you're getting it. If I write, if it is given like sigma, say r square plus 1 upon r plus 1, r from 1 to 10, then what is this? If you expand it, it is nothing but 1 square plus 1 upon 1 plus 1. This will be the first term. If you put r is equal to 1, then if you put r is equal to 2, will be the next term. So that is 2 square plus 1 upon 2 plus 1. Then you put r is equal to 3, so it is going to be 3 square plus 1 upon 3 plus 1, and up to how many terms you need to write? You can see you are ending at 10. So that means you have 10 terms in this series, and 10th term will be 10 square plus 1 upon 10 plus 1. So this is the series. All right. I hope you have got it. So now let me tell you the properties of sigma first. So first very basic property is, if you have sigma of some constant into r from 1 to n, 1 to n or whatever are the limits, so it doesn't matter. You can take this k outside the summation, k sigma ar. Like you can take k common from a series. If it is k a1, let me expand it here. Basically this was written as k a1 plus k a2 plus k a3, right, and so on up to k an. So that means you have taken k common. All right. So it is k plus k into a1 plus a2 plus a3 up to an. So it is nothing but k into sigma ai or ar, I from 1 to n. You can write I or r or m, whatever variable you want to choose. All right. So I hope you have got it. This is the first property. Second property is, if you add sigma of ar plus br. Suppose you have two terms. If you want to distribute sigma, this obviously you can distribute. You can add this series separately, sigma ar plus sigma of br. So if I expand it, you can understand it easily. So if I expand it, this was actually a1 plus b1 plus a2 plus b2 plus so on up to an plus bn. All right. So if you take first term, that is a1 plus a2 plus so on up to an, plus second term is b1 plus b2 and so on up to bn. All right. So this is the series. I hope you have got it. Now if you have sigma of some constant k, all right, then what is this? See, this is independent of r from 1 to n. It is independent of r, that means you are adding this constant, so it is nothing but k plus k plus k plus k n times, that means n into k, directly you can write. Or you can use sigma of 1 r from 1 to n. If it is a constant, sigma 1, that means you are adding 1 plus 1 plus 1 n times, so it is nothing but n. All right. So if adding 2, if it is sigma of 2 r from 1 to n, then it is 2n. If it is sigma of 3 r from 1 to n, it is 3n. All right. If you have sigma of say 10 r from 1 to say 50, then it is nothing but 50 into 10. Okay, that is the answer. So I hope you are getting it. So these are some properties, and this one is a very good property. Sigma of r starts from a to b. A and b are natural numbers or integers, you can say. You have written f of r, some function of r. So that can be written as sigma of f of a plus b minus r. See, this is the lower limit, this is the upper limit. Okay, so r can be replaced by a plus b, lower limit plus upper limit minus r, all right? And these limits will remain same. So see what is happening here, I'll explain this. If you have sigma of f of r from a to b, then it is going to be f of a plus f of a plus 1 and so on up to f of b, all right? But when you do apply that property, so you write f of a plus b minus r, all right? And r from a to b. Then you are doing nothing but you are flipping this series. The last term will become the first term and first term will become the last term. If you put r is equal to a in this, you'll get f of b, right? Then if you put r is equal to a plus 1, you'll get f of b minus 1, which is the second last term of this, all right? And keep putting the values. If you put the b minus 1, then you'll get f of a plus 1, and then last term will be f of a. Okay, so you can see these two series are same, they are just flipped, right? So by applying this, so these two are same, right? Equal. So that means if you apply this property, you are just flipping the series. Okay, flipping the series means summation will remain same. Okay, so value will not change, and this property is going to be very, very useful. All right. So we'll use this property. I'll tell you how to apply it and where to apply it, where this property is going to be useful. So in some question, it is really, really very useful. Okay, so all right. Suppose let's do one example, not of this, but of sigma. If you have sigma of 2 raised to r from say 0 to n, all right, 0 to n, then what is this written? This is written 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 and so on 2 raised to n. So which series is this? This series is nothing but geometric progression. So you can write the answer. First term into common ratio to the power number of terms n plus 1 minus 1 divided by 2 minus 1. That is 2 raised to n plus 1 minus 1. Alright. So this is the summation. I hope you got it. Now let me tell you some important values of sigma which you need to remember, and we'll directly apply these values in the question. So first value is sigma of r from 1 to n. Okay. So I'll write this important points to remember. So first sigma of r from 1 to n is nothing but 1 plus 2 plus 3 and so on up to n. Okay, and if you add this series, that is going to be n into n plus 1 by 2. All right, then this is sigma of r square r from 1 to n. So this is the second value. Sum of natural numbers, you know, right? Sum of natural numbers, you know. Now it's an AP also, it's an AP, so you can apply the formula of AP to get this sum. You need to remember this value. Similarly, this is sum of squares of natural numbers. So sigma of r square is nothing but 1 square plus 2 square. This is written, right? And what is the value of this? I'll tell you the value first. So first memorize this value. We'll start applying it and we can prove it easily. So once we learn the method of difference, I'll tell you the proof of this, all right? That's a very simple proof, not difficult. So first memorize this value, n into n plus 1 into 2n plus 1 by 6. So we'll use this value in today's session. Next is sigma r cube, sum of cubes of natural numbers, r from 1 to n. So that is basically comes out to be n into n plus 1 by 2 the whole square, which is basically square of this. So you can write this sigma of r the whole square, okay, r from 1 to n. So sigma of r cube we get as sigma of r the whole square, all right. So this comes out to be like this. Adding cubes of first n natural numbers, that will be square of sum of first n natural numbers, all right. That means if you write 1 cube plus 2 cube plus 3 cube, it is coming out to be 1 plus 2 plus 3 the whole square. You can check this, all right. If you want to check it, then check it. This is 27, this is 128. 28 plus 1 is 28 plus 8 is 36, right? 36. And you can see this is 6 square is also 36, all right. So that is what. Okay, so see how to use it. Suppose you have this product of two APs. We did product of AP and GP. So today we are going to do product of two APs. So if you have 1 into 3 plus 3 into 5 plus 5 into 7 and so on. Suppose you need to do this to n terms. You need to find the sum of this series of up to n terms. So whenever you have general term of a series as a polynomial in R, that means it can be quadratic, it can be cubic, but do not go beyond cubic, otherwise I'll get term of R raised to 4 and you do not know the answer of sigma R square, sigma R raised to 4, alright? 1 minute. Hi Abhikya. Big now. JEE 2021 we postponed. I don't know about that. If will it be postponed or not. Uh, that decision will be taken by the IITs and mm, maybe by 1 or 2 months, but not sure about that. I'm not sure about that. Okay, so we'll write the general term of this series. So if I write the general term of this series, then what will it be? 1, 3, 5. All right. So 1, 3, 5. If I write the general term, then general term of this series, the rth term, is going to be 2r minus 1, 1, 3, 5, odd numbers, 1, 3, 5. You can write. All right. Using the, these are odd numbers. You can directly write this 2r minus 1. And 3, 5, 7, these are also odd numbers. Just, but its rth term will be one extra term, okay, next to this, that is 2r plus 1, all right. So in this way you can write the rth term of this series, and after writing the rth term you can apply, you can put this in sigma. So sigma tr you need, right, r from 1 to n. So after applying this you can get sigma of 2r minus 1 into 2r plus 1 r from 1 to n, all right. Now use those values which I have just told you. So first apply the property. So it is going to be 4r square minus 1, distribute sigma, and applying the property you can write this 4 outside. So you can write in this way 4 sigma of r square minus sigma of r. Is that okay? R from 1 to n, r from 1 to n. Then put the values sigma of r square and sigma of r. Alright. So sigma of r square is nothing but n into n plus 1 into 2n plus 1 divided by 6. Alright. Minus sigma of r is nothing but n into n plus 1 by 2. Then you can take common and just simplify it and get your answer, okay, in simplified form. Although this is the answer, but you can further simplify it. So it is n into n plus 1 by 2, which is common, and then you can write 2 by 3 of 2n plus 1, 4 by 3, I'm sorry. So 4 by 3 2n plus 1 minus 1. This will be the remaining thing. If you take the LCM, it is going to be n into n plus 1 by 2 into, if you take LCM, it is going to be 8n plus 4 minus 3 divided by 3. So your final simplified answer is this, n into n plus 1 into 8n plus 1 whole divided by 3. Okay, so I hope you have got it. Have a look. Any problem? Then let me know. All right. Then I'll move to another example. Example 3. Suppose you have this series 1 square into 3 plus 4 square into 5 plus 5 square into 1 4 sorry, not 5, 7 square into 7 plus 10 square into 9 and so on, okay, up to n terms. You need to find the sum. So think about it, what is the answer, and I'll discuss with you. Alright, so now let me write the general term of this. If you write the general term TR, so TR is basically 1 square, 4 square, 7 square. So what is the rth term of this? 1, 4, 7. So this is a arithmetic progression with common difference 3. So you can write 3R. And to match the first term, put R is equal to 1. You are getting 3. So you need 1. So minus 2. Alright. So in this way, or apply the formula of rth term of an AP. So 3R minus 2 is the rth term of this series. So it is a square of this. So it is 3R minus 2 the whole square. Alright. And into 3, 5, 7, we have just done it. General term of rth term of this was 2R plus 1. So this is what we are getting this time. Alright. So it's a cubic and R. Expand it first of all. So after expanding, you'll get 9R square plus 4. 9R square plus 4 minus 12R into 2R plus 1. Now again multiply. So this is going to be 18R cube plus 8R minus 24R square plus 9R square plus 4 minus 12R. So it is going to be 9 minus 24 is 15 R square, alright, plus 8 minus 4R plus 4. So there is TR, and sigma TR is nothing but 18 times of sigma R cube minus 15 times of sigma of R square minus 4 times of sigma of R plus 4 times of sigma of 1. So 18 into, put the values and simplify it, so it is n into n plus 1 by 2 the whole square minus 15 times of sigma R square is n into n plus 1 into 2n plus 1 by 6. Alright, and sigma R is n into n plus 1 by 2 plus 4 times of sigma 1 is nothing but n. Alright, I've told you sigma 1 which is n. So in this way you can write the answer. Okay, now let's move to another problem. Suppose we have something like this: 1 cube upon 1 plus 1 cube plus 2 cube upon 1 plus 2, then 1 cube plus 2 cube plus 3 cube upon 1 plus 2 plus 3, and so on. So we need to find the sum of this up to n terms. Think about it, how to do it. Alright, so let me simplify it. If I write the general term TR, then it is 1 cube plus 2 cube plus 3 cube and so on up to R cube. I have just told you that this sum of cubes of first and natural number is the square of sum of first and natural number, right? So even if you put the formula, you'll get it R into, this is R into R plus 1 by 2 the whole square, right? And denominator is 1 by 2 of R into R plus 1. So we are applying the formula of sigma of R cube, right? See, these terms will get cancelled. So you are going to get 1 by 2 of R square plus R, alright? Then sigma, you need sigma TR. This is the R term, okay? Now you need to add it. So if you add sigma TR, it is going to be 1 by 2 of sigma of R square plus sigma of R, alright? Like this. Now put the values, you need sum of n terms. So this is going to be 1 by 2 of sigma R square is n into n plus 1 into 2n plus 1 upon 6, and sigma of R is n into n plus 1 by 2, alright. So you can take this n into n plus 1 by 2 common, and it is going to be 2n plus 1 upon 6 plus 1. All right. You can further simplify it. If you want to simplify it. It is going to be n into n plus 1. Even if you take LCM, it is going to be 2n plus 7 divided by 24. All right. That is it. Okay, so now let's do one more problem. Suppose you have this series 1 plus 3 plus 6 plus 10 plus 15 plus 21 and so on. All right. So this is a series in which by looking at the series you can't write the general term directly, right? Then what kind of series is this and how do you use sigma in this? So that's the point. So let me tell you how. This is a series in which you can see the difference of two consecutive terms, difference of this and difference of this and difference of this. Just write the difference. Difference is 2, then difference is 3, then difference is 4, then difference is 5, then difference of 6. All right. So you can see difference is forming an AP, right? These numbers are forming an AP. So in such series in which difference is forming an AP, you can assume the general term. General term is of this type: AR square plus BR plus C. Okay, but you'll have to find ABC. How to find ABC? You can put R is equal to 1. So you'll get A plus B plus C is equal to 1. Similarly, R is equal to 2 equated with 3 and R is equal to 3 and equated with 6. And you'll get 3 equations, solve these 3 equations. So this is one of the way. And the other way is, if you don't want to do this, then use method of subtraction. So what is this method of subtraction? I'll tell you. So I'll write this series 1 plus 3. So general term, the first thing you need to understand is that general term of this, rth term of this is going to be of this type, all right, AR square plus BR plus C, which is a polynomial. So if you get the rth term, then you can apply sigma and you will get the value of the sum as well, right? So now let me tell you how to find the rth term. I've told you one method. You can assume general term to be like this, then put R is equal to 1 and 2 and 3, all right, and equate it with 1, 3 and 6 because you know first, second and third term. The another method is 1 plus 3 plus 6 plus 10 plus 15. Write this series, okay, and assume the general term of this to be TR. Let's say capital TR, all right. Then again write this series by shifting one place, all right. So it is going to be 1 plus 3 plus 6 plus 10 and so on. This is going to be TR minus 1 plus TR, all right. So if you shift and subtract, this is called method of subtraction. So if you subtract, it is going to be 0 is equal to 1 plus 2 plus 3 plus 4 plus 5 and so on plus TR minus 1 minus TR, all right. So you get TR is equal to 1 plus 2 plus 3 and so on up to TR minus 1. So this is basically, let's take this small tr, okay, because small tr is rth term of this new series which you can see, right, this series, okay, it's rth term, it is coming at the rth place, and this tr I have taken to left hand side. So now by adding this series 1 plus 2 plus 3 to r terms, if you write a tr or not, whether you write tr or not doesn't matter, okay, you can leave this. So this is a series of r terms, right? You can see r terms are there in this series. So sum of this series is going to be r into r plus 1 by 2, all right? And by adding this series, you are not getting the sum of the original series, but you're getting the rth term of the original series, right? So you got rth term of the original series, tr, but you need what? You need sigma tr, r from 1 to n. So this is nothing but sigma of 1 by 2 common, and it's going to be r square plus r, all right, r from 1 to n. Then it is 1 by 2 of sigma r square. Now put the values. Sigma r square is n into n plus 1 into n plus 1 by 6 into n plus 1 by 2, all right. So this 2 is also there, so you can write 4. So if you simplify it, you can take 1 by 4 common, n into n plus 1 common, all right, and what is remaining? It is remaining 2n plus 1 by 3 plus 1, all right. So finally, if you take LCM, it is going to be 2n plus 4, then again 2 you can take common, so your final answer is going to be 1 by 6 n into n plus 1 into 2n plus 1. So this was a series in which difference of two consecutive terms was forming an AP, and this is the way to do it, method of subtraction, all right. And another method I have told you to assume this general term TR, and by putting R is equal to 1, 2, and 3 and comparing it with these three terms, you'll have to solve the equation. So A, B, C, and you'll get the general term, all right. So A will come out to be 1 by 2. Again, you can see A is coming out to be 1 by 2, B is also coming out to be 1 by 2, and C will be 0, all right. So if you compare it with C, A plus B is 1, right? So in this way you can compare. I hope you have got it. So this was about the sigma, and this is a short topic, very small topic. So I'll finish it here. I'll continue method of subtraction in next session. All right, method of telescoping series. Okay, difference method. So we'll start difference method from our next session. All right. So till then, take care. All right, thank you very much. Subscribe the channel and like the videos if you enjoy watching it. Thank you very much.